The moment hydrogen peroxide touches this filthy air conditioning coil, the reaction looks convincing. White foam expands across the black buildup, brown liquid begins running into the drain pan. Within seconds, one section of metal appears brighter. It looks as if a $3 bottle has done the job of an HVAC technician. But the important question is not whether peroxide can make dirt bubble. The question is what happens to the coil, the drain, the electrical parts, and the air in your home after the foam disappears. Today, we are going to uncover 9 things HVAC technicians understand about hydrogen peroxide that most viral cleaning videos leave out. Some explain where peroxide may help. Others reveal why pouring it into the wrong opening can turn a dirty air conditioner into an expensive repair. And the final one changes how you should judge every dramatic cleaning result you are about to see. Before anything touches the equipment, the system is switched off at the thermostat and at the electrical disconnect or breaker. An indoor air handler contains wiring, controls, motors, and components that should not be exposed to careless spraying. Turning the thermostat off alone may not isolate every energized part. Access panels should not be opened unless the power is safely disconnected and the manufacturer's instructions permit homeowner access. If you cannot identify the coil, drain pan, and electrical compartment with certainty, stop there. Number 1. The bubbles are not proof that the entire surface has been disinfected. Hydrogen peroxide naturally breaks down into water and oxygen. When it contacts certain organic material and enzymes, that breakdown can accelerate, producing the familiar white fizz. On a dirty HVAC surface, trapped air, dust, biological residue, and the rough texture of the buildup can make the reaction look enormous. But the size of the foam does not tell you which organism was present, how deep the contamination goes, or whether every part of it received an effective treatment. A black patch inside an air conditioner may contain ordinary dust mixed with moisture, degraded insulation, greasy household particles, microbial growth, or several of these at once. Peroxide may lighten part of that material without removing the physical layer underneath. And a disinfectant works only when the correct product reaches a compatible, pre-cleaned surface for the contact time written on its label. A grocery store bottle that says 3% hydrogen peroxide is not automatically labeled for every HVAC surface or every microorganism. Watch the first treated area after the foam is wiped away. The metal looks brighter, but a cotton swab still collects a dark film from between the fins. That is the first secret. A chemical reaction can change the appearance of contamination before the contamination has actually been removed. Number 2. A dirty evaporator coil is primarily an airflow and heat transfer problem. The evaporator coil is made from rows of extremely thin metal fins wrapped around refrigerant tubing. Air must pass through those narrow spaces. When dust collects on the leading edge, it acts like insulation and restricts airflow. The air conditioner may run longer, cool poorly, use more electricity, or allow the coil to become too cold and freeze. Peroxide cannot solve that simply by whitening the visible face. Professional coil cleaning begins with diagnosis. Is the filter missing or overloaded? Is the blower moving enough air? Is the dirt dry and loose, or is it bonded with oil? Is the coil accessible from both sides? Manufacturer guidance commonly calls for shutting down the system, removing loose debris carefully, and using a compatible coil cleaning method. Some light dirt may be removed with a soft brush or vacuum. Greasy material may require a mild detergent or a purpose-made coil product. The exact method depends on the equipment. Now compare the treated stripe with the untreated stripe using a flashlight from behind the coil. Both still block much of the light. The peroxide changed the color, but it did not reopen the passages. Until air can move through the entire depth of the coil, the problem remains. Number 3. Those shiny fins are much easier to damage than they appear. Evaporator fins can bend with surprisingly little pressure. A stiff brush, high-pressure spray, or aggressive wiping can flatten them into a wall that blocks air. The tubing, soldered connections, protective coatings, plastic drain pan, sealants, and cabinet insulation may all have different chemical compatibility limits. A cleaner that is acceptable for one coil is not automatically safe for another. Hydrogen peroxide is an oxidizing chemical. Household strength is far less concentrated than industrial products, but that does not make repeated soaking universally compatible with every metal, coating, adhesive, or plastic inside an HVAC system. There are commercial peroxide-based coil cleaners, yet those are formulated, tested, diluted, and labeled for particular uses. Their existence does not prove that an unlabeled brown bottle from the medicine cabinet is an equivalent substitute. This is why an experienced technician checks the model, coil material, coating, product label, and rinse instructions before applying anything. If a coil has a special protective finish, using an unapproved chemical may discolor it, reduce protection, or complicate a warranty claim. The hidden cost is not always an immediate hole in the metal. It may be a surface that begins collecting dirt faster or deteriorating sooner. Number 4. The most expensive parts may be only inches from the satisfying foam. Look beyond the coil. Depending on the air handler, there may be a blower motor, circuit board, transformer, sensors, wire terminals, insulation, and safety switches inside the same cabinet. Gravity pulls liquid down, but a spray creates droplets that travel sideways. Foam can expand into seams. Runoff can follow wiring or collect beneath components where you cannot see it. Peroxide on an exposed plastic drain cap is one situation. Peroxide mist across electrical controls is completely different. Even if the system is powered off, liquid residue must not be left on electronics before power is restored. Wet insulation can hold moisture and develop its own odor. A soaked cabinet can also leak onto ceilings, flooring, or the furnace below. That is why the dramatic thumbnail version of this experiment is dangerous when copied literally. Pouring an open bottle across the face of an installed coil gives you almost no control over volume, direction, or runoff. A technician protects adjacent components, uses controlled application, collects wastewater, and confirms the cabinet is dry before reassembly. The secret is not a stronger chemical. It is controlling where every drop goes. Number 5. The drain pan can look clean while the drainage system is still failing. Every cooling cycle pulls moisture from indoor air. Water forms on the cold coil, falls into the condensate pan, and exits through a drain line. Dust that bypasses the filter can mix with this water and create dark sludge. That damp reservoir can support odor and microbial growth, especially if the pan holds standing water. When peroxide lands in the pan, it may foam through the upper layer and loosen some residue. The immediate result looks excellent. But now examine the corners, the outlet opening, and the underside of the coil. Thick debris remains where the liquid never reached. More importantly, the pan may be cracked, rusted, poorly sloped, or overflowing because the outlet is blocked. No chemical can repair a damaged pan or correct its pitch. The real test is drainage. After loose material is physically removed using the method approved for the unit, clean water should travel freely from the pan to the exterior discharge. There should be no standing water, no leak around the cabinet, and no float switch shutdown. If water remains after the bright surface is dried, the visible cleaning result was only cosmetic. Number 6. Pouring peroxide into a clogged condensate line can move the problem without removing it. A drain line clog is often a compact mixture of dust, slime, algae-like growth, and debris. Peroxide may react with organic material near the access opening, but it cannot guarantee that a blockage several feet away has been cleared. Expanding foam can loosen fragments that travel farther down the pipe and settle at an elbow. The top appears open while the restriction simply changes location. Professionals commonly clear a clogged line mechanically, often by pulling the obstruction from the exterior outlet with a wet-dry vacuum or using an appropriate snake or controlled water pressure. Then they test the full path with clean water. Some manufacturers describe specific maintenance liquids for their drain lines, but recommendations vary. Never assume peroxide, vinegar, or bleach is approved for your exact installation. And never add peroxide to a drain that may still contain another cleaner. Hydrogen peroxide should not be mixed with bleach or other household chemicals. If you do not know what was poured into that pipe before, adding a second product is a chemical gamble inside a line connected to the air handler. The safe question is not, what can I pour next? It is, what is blocking the line, and how do I remove it completely? Number 7. A disposable air filter should not become a peroxide sponge. A dirty pleated filter can appear gray, stained, or even spotted. Spraying it with peroxide may make the surface look fresher, but it also turns captured dust into wet material. Moisture can weaken the filter media, disturb its structure, increase resistance, and create a damp object directly in the airflow. When the fan starts, loosened particles or droplets may move downstream toward the blower and coil. If the filter is labeled disposable, replacement is the maintenance procedure. Match the correct dimensions and a filtration rating suitable for the system. A filter that is too restrictive can reduce airflow just as surely as a dirty one. If the equipment uses a washable permanent filter, follow its cleaning instructions and allow it to dry completely before reinstalling it. Do not invent a peroxide treatment simply because the material looks reusable. This small distinction matters because many dirty coil problems begin at the filter. A poorly fitted filter leaves gaps. An overloaded filter reduces airflow. A missing filter allows the coil to collect everything. Whitening the old filter does not restore its ability to capture particles or correct a bad fit. Number 8. Spraying peroxide into vents does not clean a contaminated duct system. A return grill covered with dust is visible, accessible, and tempting. Remove and clean the grill according to its finish and manufacturer guidance, and it may look new. But the grill is not the duct. Behind it may be bare sheet metal, fiberglass liner, flexible duct, insulation, damp debris, or nothing more than ordinary household dust. Each material requires a different decision. The EPA warns that biocides should be used in duct systems only where the product label specifically allows that use. Porous or internally lined ductwork presents a special problem because contaminated insulation may not be effectively cleanable, and indiscriminate spraying can add moisture without removing the source. A fine peroxide mist sent into a return can also be carried toward the filter, blower, coil, and occupied rooms. If substantial mold contamination is suspected inside the HVAC system, do not use the fan to spread material through the building. Identify the moisture source and have the system evaluated. Sometimes the correct response is physical cleaning of compatible hard surfaces. Sometimes wet, porous material must be replaced. A bottle sprayed through a vent cannot make that diagnosis. Number 9. If the moisture problem remains, the smell and growth will return. This is the secret that separates a 1-minute transformation from a repair. Mold and odor inside an HVAC system are not created by a shortage of peroxide. They are created by moisture, nutrients, temperature, and time. The moisture may come from normal condensation combined with poor drainage, a clogged line, a cracked pan, high indoor humidity, air leakage around the cabinet, missing insulation, a frozen coil, or water entering from somewhere outside the system. After our treated coil and pan dry, the black surface looks reduced, but the system is not declared clean yet. Airflow is checked, the filter fits, the drain accepts clean water. The cabinet does not leak. The float switch works. The coil does not freeze. The system is allowed to run, and then it is inspected again for standing water and returning odor. That delayed test is far more meaningful than the original foam. There is also a health clue the bottle cannot diagnose. A musty odor can come from a wet coil or drain, but also from damp insulation, a soiled blower, a plumbing trap, or moisture elsewhere in the building. Masking the smell does not identify its source. If contamination covers a large area or returns quickly, stop experimenting. Document where water appears, when the odor is strongest, and whether it changes when the fan runs. Those details help locate the actual failure instead of treating the wrong surface. Hydrogen peroxide can be an effective ingredient in properly labeled disinfectants and formulated HVAC cleaners. But concentration, surface compatibility, pre-cleaning, application method, contact time, rinsing, and drying all determine the result. An ordinary 3% bottle provides none of those answers by itself. Read the equipment manual and the cleaner label. Use only products approved for the intended surface and location. Wear the protection named on the label. Ventilate the work area, and never mix cleaning chemicals. So here is the honest verdict. Hydrogen peroxide may lighten exposed organic staining and loosen limited residue on a compatible, removable surface. It may also create spectacular foam that makes an incomplete job look finished. It cannot straighten fins, restore airflow, repair a pan, pull a solid clog from a drain, dry wet insulation, protect electrical controls, or eliminate the condition that caused growth. The technician's advantage is not a secret miracle bottle. It is knowing that an HVAC system is a connected chain. The filter affects the coil feeds the pan feeds the drain. Moisture affects the duct and the air returning to your rooms. Treat one black patch without testing the chain, and the problem waits out of sight. Restore airflow, remove debris, clear drainage, protect the equipment, control moisture, and then judge the system after it runs. That is what the foam never shows you.